Hello friends, it's Uncle Sam again, and we've been solving questions on the exact ODE and the integrating factor, and we have another question here we need to solve, and this we also need to test for the exactness of the equation before we start solving the ODE. So let's call this question question 2, and this is the question here. We have 3x plus 2x, no, plus 2y dx plus x dy equals what? 0. So we need to test first if it is exact or not. If you still remember from the previous video, we have this as our hem, right? We have this as n, and we need to test by saying the hem, the y equal what? This is 3x. You're differentiating this with respect to y. So this will be what? 0. And here you have this as 2. Then let's go to the dn dx. This will give you what? Just 1 because you just have x here. So you have 1. Since you have the m dy as 2 and the n dx as 1, they are not equal. So the m dy is not equal to the n dx. Therefore, it is not exact. So if it is not exact, what do we need to do? We need to move to the integrating factor. We need to find the integrating factor. And how do you find the integrating factor? You introduce a function rx, right? So from the explanation of the integrating factor, I mentioned that it's either you find rx or you find ry. But let's find rx first, then we move to ry. So if you're looking for rx, your answer needs to be in terms of x. That is, it has to be a function of x. If you find rx and you got, let's say, x plus y, that is y is still in the equation, then it's not, then you cannot use rx. Then you need to move forward, then solve for ry. Then if you solve for ry, you need to find ry in terms of y, in terms of only y. So that is, ry has to be a function of y only without x. Let us find rx. Rx has this formula of what? 1 over q. You have 1 over q, brackets, the p, the y, minus the q, the x, then close brackets. What is our q? So this will change. Our hand will change to what? Our p, and our hand will change to our q. Let me just write this. P equals 3x plus 2y, and our q equals what? X. 1 over q is going to be 1 over x, open brackets, the p dy, comma, let's write our dp dy here. The p dy will be, this will be 0, right? And this will be 2. You have 2 minus, then our dq dx will be what? Dq dx will be 1, so minus 1. Then you have what? 1 over x. So can you see rx here is a function of x because you only have x here. So then we'll be able to use this value of x, this value of rx into, like, we can continue with our rx instead of moving to ry. But for the sake of solving, let us solve for ry. We won't be using it, but let us solve for ry. So assuming you solve for rx and you were not able to get this as a function of y, no, as a function of x, then let us see if y will be able to get as a function of y. Ry equals what? 1 over p, open brackets, the q, the x, minus the p, the y, which is what? 1 over p is 1 over 3x plus 2y, open brackets. What is our dq dx? Dq dx is 1, minus the p dy is 2. So you have negative of 1 over 3x plus 2y. If you check this, we are supposed to have only r as a function of y only without having x. That means this should be cancelled. That means you cannot use ry as you cannot put it into the integrating factor equation. So let us find the integrating factor. Let's go back to rx and let's find the integrating factor. If you go back to the previous video where I explained the integrating factor formula is going to be exponential integral rx, then the x, right, equals what? Exponential integral. Then our rx is what? 1 over 2. sorry, 1 over x dx. Then you have what's exponential integration of 1 over x is going to give you ln x, right? Then exponential can cancel ln, then you have it as x. So this same x, you have to multiply this value. So our integrating factor is this. So you have to multiply this whole equation by the integrating factor, which is x. Then let's go to the next page. So we have x multiplied by 3x plus 2y dx plus x multiplied by what? X squared dy equals what? 0. Here you have 3x squared plus 2xy dx plus x cubed dy equals 0. So you've multiplied with the integrating factor. Then what you need to do is to test if the integrating factor has affected it to be exact or not. So if it is not exact, then you are multiplying with the wrong integrating factor. So let us name this our new hem, right? And let us name this hen. The m dy equals what? So you need to differentiate this with respect to y. So this will give you 0, right? And this here will give you 2x. And also the n dx, the n dx is going to give you, oh, there's a mistake here. Let me go back. We have x, not x squared. My bad. So you have x here, not x squared. So you have here to be x squared. And the n dx is going to be what? 2x. So from here, you'll be able to say the m dy equals what? The n dx, which equals what? 2x. So now it is exact. Then you can move on by solving the ODE, introducing another function of the u dx from ham, du dx equals to ham, du dy equals to hen. Then you find the u, then you introduce your um, constants, and you'll be able to put u as a constant. Just the same step we followed, like the previous video. Now let us introduce the u dx as m and the u dy as n. So u equals what? Integrating m with respect to x. Therefore, we have u as, what's our m? M will be 3x squared plus 2xy, then the x. Then don't forget to add the constant, which is the function of y, not x. Don't make that mistake. Then u equals what? So you need to integrate this. When you integrate with respect to x, you have what? 3x squared, x cubed rather, over 3 plus 2x squared y over 2 plus the function of y, which is our constant. 3 can cancel 3, then 2 will cancel 2. You have u as x cubed plus x squared y plus f function of y. Then let's recall the value of u of du dy, which is n, which is what? X squared. Therefore, you can say d dy. Since you found the value for u, but not complete because you still have the value of fy, which you need to solve, then you put in the value of u here plus x squared y plus f as a function of y, then equals what? X squared. Let's differentiate this with respect to y. You have here as 0 because there's no y here. Then when you differentiate this with respect to y, you have x squared because this will change to 1, right? You have x squared, then plus fy equals what? X squared. You can cancel this. You have f function of y to be 0. Then when you differentiate this, you actually have f prime. So don't forget that. F prime equals 0. Then f as a function of y will then be a constant. Then you can put this value into this equation. So you have u to be what? Oh, you can put it into this equation. Equals what? X cubed plus x squared y, then plus c. Then since u is going to be a constant also, so that will override this. And so we have x cubed plus x squared y equals constant from the, the u equals 0. So which will make what? U equals constant. So you have this as your constant, as your ODE. Thank you very much. Bye.